This is also the kickoff of a series we're doing this year, celebrating our historic 24-inch Clark Refractor, because this is its 125th anniversary. It saw first light this year on July 23rd. So starting in May and continuing through the end of the year, we're going to have a monthly program, kind of following the formula of tonight, where we'll talk about some historic aspect of the telescope and dome, and then we'll view an object through the telescope that's something that one of our scientists studied through the years. So tonight we're going to be viewing the Sombrero Galaxy, and that was really critical to work that Vesto Slipher did. And then we'll have one of our scientists on, or another guest, talking about the importance of that research and how it connects to their research today. So it's a great opportunity to learn about this heritage of science we have going on at the observatory. My name is Kevin Schindler, and I'm the historian at Lowell Observatory. And it's my pleasure to welcome everybody, and a special welcome to a young fellow named Senna, a future scientist perhaps. We're glad to have you here tonight. So the Clark telescope, we're going to be talking about that tonight, and we're going to have live views. I'm in my office here at Lowell Observatory. It's really great how we do virtual, because Deidre Hunter, who will be joining us later, is at her home. I'm in my office. Danielle Adams, one of our behind the scenes gurus making this all work, is in the Clark Dome. And then Heather Craig, another of our behind the scenes people, is at her home. So we're spread all over, but that's what we do with virtual. So every month, like I said, we're going to talk about some aspect of the Clark telescope. So one month we'll talk about how the dome rotates. Other month we might talk about the type of the instruments we use and such. But since this is National Astronomy Day, where we're kind of looking at popularizing science and the excitement of science and space, tonight we're going to talk about the Clark telescope and pop culture through the years. And the telescope was built in 1896, and it's been in pop culture a lot. So let me start my program. Let me share my program here. And just a second. And in theory, you see a slide here. The headline is "Martians Build Two Immense Canals." This is, if you look at the top, this is from the New York Times. So our founder, Percival Lowell, really popularized science. Many have called him the Carl Sagan of his time, because he did science, but he also wrote popular books. He gave invigorating talks that people really enjoyed hearing. And he really started this idea of promoting what we're doing, getting into pop culture, into the popular mind. And so he was, like I said, he was a great speaker. He made headlines. And so early on, Lowell was in the newspapers. Here's some of these pictures I show are a little fuzzy tonight, because these are pictures copied from old newspapers or from videos and other stuff like that. But this one is great because it shows the Clark. This is a newspaper article from 1911 showing the Clark telescope. So from the beginning, even though people might not have been here at the observatory, they were still learning about the Clark telescope because of Percival Lowell. He wrote several books based on his observations and what he thought his observations meant. And these are popular publications, and they were well read. A lot of people bought them and went through them. And so early on, Percival built this awareness. So the observatory and the Clark telescope has been featured in books through the years, and certainly a lot of newspaper and magazine articles that built this popular awareness. It's been featured in art. If you're from Northern Arizona particularly, you might be familiar with Roberta Rogers, a very talented watercolorist. This is a painting she did a few years ago of the dome. And here's of Santa Claus in big red, Percival Lowell's car in front of the dome. And this would represent years ago when the Saturn Gate, which is now next to our parking lot, our visitor center parking lot. Before 1994, it was by the Clark Dome. So it's been featured in this sort of art. There's another artist that many of you are familiar with if you follow Lowell Observatory. His name is Greg Mort. Greg has been on our advisory board for years and is just a really talented person. He contributes so much as a board member, but he's a world-renowned artist. And right here, he's working on Mars globes based on the globes that Percival Lowell made with the Clark looking at Mars. In 1994, to celebrate the centennial of Lowell Observatory, Greg painted this montage of Lowell history and featured prominently on either side of our founder, Percival Lowell. On one side is the 24-inch Clark Refractor, on the other side is his dome. So really centered in that story. And if you visit Lowell, if you visit one of the scientists or other staff members here, you might see this painting is hanging in the hallway of one of the office buildings, actually right below where I'm sitting right now. And then, gosh, in the late 1990s, Greg did something else. He made this really fantastic model of the Clark Dome and telescope. And this is our PR person at the time, Cynthia Canner. And she's standing at the White House where this was on display. And here's a close-up of that model. I wish we had this model here today, but it's over in Washington, D.C. So again, the Clark and the telescope, it has this heritage of science that's gone on for so long that it was deemed important enough to be represented in art like this. And if we talk about pop culture, what more is pop culture than the Oscar Mayer Wienermobile, which has visited the observatory a couple times. So that's kind of neat. In a lot of different ways, we see that it's been represented. So I want to talk about something else now, kind of the feature of this historic park tonight. And while I'm doing this, I think we can go to a live view of the interior of the Clark Dome, just so you can kind of see that as I'm talking. So this picture I'm showing you, some of you might be familiar with this. This is Disneyland on opening day in 1955, and specifically, this is Tomorrowland. Well, I was talking about different ways that the Clark has been featured in pop culture. The one that I really want to focus on is educational programming, because if you go back to the beginning of educational programming on TV and such, the Clark has been featured in virtually everything you can think of. Back in 1955, when Disney opened, Walt Disney was a pretty smart guy and decided to start creating TV programs, partly to excite people about science and other things, but also as kind of advertising for the park. And so in 1957, as part of the series, they created a show called Mars and Beyond. And this featured Werner von Braun, who was the rocket guru in charge of everything here in the United States. So they talked about him, about the rocketry it would take to get to Mars, but also they wanted to talk to a Mars expert. And so Percival Lowell was long gone, but E.C. Slipher, who some of you might be familiar with his name, he was one of the world's most respected Mars experts. And so Disney Productions contacted the observatory, and E.C. Slipher was contracted to go on the show. The Disney people visited here in April of 1956. And you see this is a drawing made by Ward Kimball's wife, showing Ward Kimball viewing through the Clark, looking for canals on Mars, as it were. You might be familiar with the name Ward Kimball. He was one of the classic illustrators at Disney. And among other things, he created Jiminy Cricket, among other Walt Disney things. So he and the Disney crew came here. They interviewed E.C. Slipher, and this is E.C. Slipher right here. And one of the great stories with this is that they put glasses on him so he would look more like an astronomer. And sure enough, the feedback was, well, that guy really does look like an astronomer. Continuing the stereotype of men with glasses, nerdy looking guys. And then in addition to interviewing him, which was actually at the studio, they also came to the observatory, and here's E.C. Slipher with the Clark. And you can still see this video. In fact, if you have Disney Plus, you can watch this video. It's also available on DVDs. So some of the earliest educational programming, this Disney programming, featured the Clark telescope. We jump years later. And again, this is fuzzy, just like the last picture. This is a picture of Carl Sagan doing the original Cosmos series. And this is from a video, it's a still. And so the original Cosmos series, one of the episodes, Blues for a Red Planet, featured Carl Sagan at the Clark telescope. And if you haven't seen this, or if you haven't seen it in a while, I encourage you to go online. I think you can find the episode. But it's really fabulous to look at that series. It inspires so many people to go into space. And Carl Sagan, listening to him speak, still gives me chills. Even though he passed away years ago, he was just such a compelling speaker, and really a lot of the ways, as our founder, Percival Lowell was. So we have Disney, Cosmos. Here's a pretty sketchy looking guy. This is in the 1990s. Bill Nye, the Science Guy, made several different series. One of them was called Bill Nye, the Science Guy. So he was here to film that series. And I think this was season 4, episode 9, or something like that, in which he was talking about pseudoscience. So he came here to talk about some of the research that Percival Lowell did and how we look at things in space and know what to believe and what not to believe. We jump ahead a little bit further. This is still the late 1990s. And the fellow on the left you might recognize as Mr. Spock, or in real life, Leonard Nimoy, who at that time hosted an educational series. And here he is at the Clark Refractor interviewing Carolyn Shoemaker, a Comet hunter. Carolyn and her husband, Gene Shoemaker, are legends in the astronomy and geology world. And so this is when they were doing an interview there. So you get the idea. There's a lot of different ways it was featured. This fella, these are two really outstanding educators. The one on the right is Neil deGrasse Tyson, who actually was not here doing a program. He was here on vacation. But on the left is Todd Gonzalez, who is just an outstanding educator here at Lowell Observatory. If you've come up here and seen any educational programming, Todd had something to do with that. Ira Flatow, you might be familiar with NPR and Science Friday. Several years ago, in conjunction with our Flagstaff Festival of Science, he was here. And the program was actually down at Northern Arizona University, but as part of his visit, a visit wouldn't be complete without visiting the Clark telescope. So here he is with our director, Jeff Hull, who is, again, you think about Lowell Observatory and the excellent science and sharing that science with the public. That all starts with the leadership of the observatory, and that's our sole trustee, Lowell Putnam, who is Percival Lowell's great-grandnephew, and Jeff Hull, our director, who's been the director for years now, and continues this tradition of cutting-edge science and sharing that science, whether it's through scientific publications or with the public. Again, a sketchy-looking guy. I apologize for this, but again, as an example of how educational programming has evolved, we have, in the old days, there were a few channels like PBS, and there's some programming that happened, but in modern times, we have History Channel, Discovery Channel, Science Channel. In this case, C-SPAN was here a couple of years ago, talking about Flagstaff and Lowell Observatory's lunar legacy. All the astronauts who went to the moon trained in Flagstaff, several of them up here at Lowell Observatory and looked through the Clark telescope. And so this, again, was the place where we, did this filming. So you can see that the Clark has been featured in a lot of places, and it's such a photogenic place, but it also is because of the research that was done with this. The work by Percival Lowell in his Mars research, V.M. Slipher's study of what we know today as galaxies, which really changed our understanding of the universe. It told us it was much bigger and older. Moon mapping in the 1960s. There was so much great stuff done with it that is still is featured in so much educational programming. And that certainly helps us build the awareness about the Clark telescope and Lowell Observatory. And that's why the Clark is such a big part of popular culture. It's just been featured in so many places, and that continues today. One last thing that I want to show before we move on with our program, another place that has been featured is a TV show you might be familiar with, The Big Bang Theory. Years ago, my family and I used to watch this pretty regularly. And I remember periodically we would be watching, and there's all this astronomy stuff. You see these astronomy pictures everywhere. And I remember thinking, gosh, I remember in some scenes there's a picture of a telescope. So one day I was waiting for the family to come home. I'm watching Big Bang Theory, and the picture comes up close up, and I took a picture. I took a picture of my TV. This is my picture of TV. And that poster is not just a poster of a telescope, that's the Clark Refractor. And I recognized this poster that was hanging there. That fellow down there is Leonard Martin. Here's let me see, I think I have another picture. Here's the actual picture. Leonard Martin was a Mars researcher for years. He's looking, and there's Mars up in the sky. So I ended up, it was a good excuse to go back and watch all the Big Bang theories. And it turns out that in the first season, that poster was hanging on one of the closet doors of Leonard and Sheldon. And then in later years, it wasn't there anymore. They changed the set. But anyways, when you make the Big Bang Theory, gosh, you've made it somehow big. So let me stop sharing here. And let me just go back here. And so as you can see, the telescope has really been featured in so many different ways. And again, that goes back to the research that was done with it. So I'd like to talk about that some now. And it ties in with what we're hopefully going to be looking at a little bit later, and that's the Sombrero Galaxy. So to help me talk about some of this research and her own research, I'll ask Deidre Hunter to join us. Dr. Deidre Hunter is one of our senior astronomers here. And by senior astronomers, I mean she's been here longer than many of the other scientists here since the 1980s. And she's built a remarkable career on studying galaxies, and particularly dwarf galaxies. And as we'll find out as we're talking tonight, there's some pretty good tie-in with what Deidre does with what VM Slipher did more than a century ago. So Deidre, welcome. Let's have you, I think you're on, so say hello so we know we can hear you.
Hi there.
Okay, that's great. Thanks for joining us tonight. And, since this is National Astronomy Day, let's maybe start by just talking about, how you got into science. This has been your career, and you've worked your entire professional career here at Lowell Observatory, which is a tradition carried out that continues by the likes of VM Slipher did that, E.C. Slipher's brother, you're doing that. So how did you get interested in astronomy in the first place?
It was the Apollo program. When I was in 9th grade, Apollo 11 went to the moon, and Neil Armstrong stepped on the moon for the first time. But even before that, my friend and I, the summer between 6th and 7th grade, we decided we were going to be the first women astronauts. And I just thought that would be so cool to go to another planet or moon and walk on that planet. However, in those days, astronauts were all pilots, test pilots even. And my dad, who was a pilot in the Army, knew that you could not be a pilot if you wore glasses. So I was suddenly lost my career because even then I already was wearing glasses. And so I decided that if I couldn't go into space, I would study what was out there, and that meant I would be an astronomer. And so that's what I did.
I was going to say, and you haven't looked back since, but you really do look back. That's what you do as an astronomer. You're looking back in time. How did you get interested in your current research?
Well,
And
when
talk about your current research a little bit.
yeah. So what I study are dwarf irregular galaxies. I have spent my entire career on these little galaxies, trying to understand how they make stars and evolve over time. And so when I went to, so I went through college, and then I went to graduate school, and I was interested in becoming, I thought, a theoretical cosmologist. I wanted to study the evolution of the universe. Um, but I was in the physics department at the University of Illinois in Champaign-Urbana, and I had fellow students who were working in laboratories doing physics experiments. And I thought, well, that seems like more fun than doing theory. And so then I came across a new faculty person in the astronomy department, Jay Gallagher, and I asked him if I could do my PhD dissertation project with him, and he said yes. And so then the question was what to do it on. And I really knew very little. I just sort of sat there looking at books and things, not knowing what to do. And he said, well, so my thesis advisor said to me, well, why don't you look into irregular two galaxies? And I didn't know what those were. So I started looking into that, and I made a plot of the color of these irregular two galaxies, one color versus another color. And I plotted the average colors for spiral galaxies. And I looked at it, and the spiral galaxies, dropped off like this, and the dwarf galaxies were all over the place. And so I asked my thesis advisor, why is that? And he said, that's a good question. And so I started studying dwarf galaxies then, trying to understand their properties and their evolutionary histories, and I just kept doing it.
Well, we're glad that you did. And this is our first night of celebrating the Clark 125th anniversary of our first monthly program, doing that for this year as part of our National Astronomy Day coverage tonight. And I can't really think of a better person to join us, because as we look at this live view at the interior of the 24-inch refractor, of course it brings us to our founder, Percival Lowell. And Percival Lowell founded the observatory to do science, of course, but he also said essentially, what's the point of doing science unless you share it with people? And that's really a key element of what we do today, is communicating science, whether it's by you, Deidre, writing up your results in research papers, or by speaking with our visitors who come up here in school groups and such. And Deidre, you have such a special connection to Lowell, not just because you've been here for a while and because you research, but you really carry on that tradition that Percival Lowell started, because you not only carry out research, but you started an educational program here that's been now going on for 28 years?
25.
25? Okay, gosh. So maybe you can talk about that a little bit, because it really, again, is at the core of Lowell Observatory and why this observatory is so special, because of that communicating science part of it.
Well, so in 1996, there was a postdoc here at the time who's now come back and is again on the faculty at Lowell.
They always come back.
They always come back. And I was there, and we were both interested in outreach. And I had dabbled a little bit with trying to put together a project that would have us doing things with teachers on the Navajo and Hopi Nations schools out there. Anyway, Bob Millis, who was the director at the time, brought Amanda and myself together. And Amanda and I put together an outreach program, which is now called the Native American Astronomy Outreach Program, NAAOP.
Mm-hmm.
And we modeled it after the Astronomical Society of the Pacific's ASTRO program. And in this, we pair astronomers at Lowell with, or educators with teachers at schools on the Hopi or Navajo and now Apache nations. And we work with 4th through 8th grade teachers and their classes. And so for a year, the astronomer works with their partner teacher and goes out and makes classroom visits, does hands-on astronomy activities. And of course, we do star parties and they have field trips to Lowell. And then we also, several years ago, started residential summer camps for rising 6th and 7th graders here at Lowell in the summer. We also, a few years ago, undertook curriculum development. You mentioned Todd Gonzalez, and he helped us develop curriculum units for 4th through 8th grade. So that we could, these curriculum units are project-based, and this allows us, we were trying to come up with curriculum that would allow the students to have a little bit more freedom of exploring how to do a project than we had been doing before with we were doing hands-on activities, but these are more open-ended so that the students could feel that they were really being a scientist. And we also involved collaborators on the Navajo Nation, a person there who helped us integrate cultural connections so that it would feel more relevant to the students. We were hoping that these curriculum units that we're now using would be better at helping students see STEM as fun and STEM careers for themselves.
So it's really a fabulous contribution, really rounding out how we communicate science here. Our scientists, give professional papers and talks. Our educators welcome visitors here to the observatory. And then we also reach out to communities, and in this case, underserved communities that might not otherwise have access to this. So it really is a great part of that mission of just trying to excite people about space. And it's just, I think everybody here is, pretty eager to do it because this is fun stuff. It's a great way to spend your career helping others, helping excite others about the universe around us. So in just a few minutes, we're gonna hopefully look at the Sombrero Galaxy through the Clark Refractor. I think we still have a picture of what's happening inside of the dome right now, but we're waiting for it to get a little bit darker because the object we're hoping to look at, the Sombrero Galaxy, is fairly faint. And it's magnitude 8, as we would say in astronomy, which means it's too faint to see with the unaided eye. You need a telescope or something like that to see it, and the sky has to be dark enough. So let's just talk about the Sombrero a little bit before we go up to viewing, and then we can also talk about how that ties in with your research. So just a little brief thing, we go back to 1912, Percival Lowell was studying planets. He was looking how not only at possible life on Mars, but he was trying to understand how planets formed. And so he directed V.M. Slipher, one of his assistants, to set up a spectrograph attached to the 24-inch refractor and look at these fuzzy blobs in space that were called spiral nebulae. And a spectrograph is something that allows you to look at light coming from different objects in space, and you can break the light down and understand what makes that light, what elements are in that celestial object. As it turns out, you can also tell if something is moving toward you, away from you, based on the Doppler shift. Well, VM Slipher was looking at these fuzzy blobs. First one he looked at was the Andromeda Galaxy, and he found that actually it was moving towards us. And then he looked at another one, the Sombrero Galaxy, and the Sombrero was the first one he looked at that it was moving away from us really fast, like something like 3,000 times the speed of sound, much faster than anything had ever been measured before. And this really, I wouldn't say shook up astronomy world yet, because nobody knew what to make of it, except that he was making these incredible observations, and he was capturing images through the spectrograph, not just like with the camera as a split second. He was doing them for hours, sometimes 40 hours, in which he would set the telescope, the spectrograph one night. It would track all the way all night. When it got too low in the sky, to close the telescope. Next night, set it up again, start that exposure again. It really is mind-boggling what he did, and it was unprecedented. Nobody had ever done that before. But what he found by taking, because these are so faint, making an exposure that was that long just so he could make these observations. So it was really remarkable what he did. And what's neat about that, before we talk about that more, is that, gosh, 100 plus years later, we were testing the Lowell Discovery Telescope, and one of the first things our scientists and engineers looked at was the Sombrero Galaxy, to check the optics and everything. So it was kind of a neat thing. And in fact, we have an image of the Sombrero taken with the Lowell Discovery Telescope and an imager on there. And I believe that's what's up on the screen right now. Yep. So it's neat that was one of the first light images. And it also has such a great history with VM Slipher being the first, what we know today as galaxies he measured that was moving away from us. So Deidre, maybe you can talk about that a little bit. And, that discovery that Slipher made, what did that do for astronomy? How did that change how we look at the universe?
Really it was one of those transformative moments in history. Another thing that I want to mention first is that VM Slipher's contribution wasn't just observing these galaxies, but he also modified the spectrograph that I think he had somebody made it for. He had commissioned someone to have it made for him.
Yeah, Brashear Instruments.
But he modified it so that it was a faster camera. Mm-hmm. And that meant that he could, even though he had to spend multiple nights getting spectra of these galaxies, that was still made it far more feasible than it would have been with the original spectrograph. So that was an innovation. But when he found that these galaxies, these nebulae, in those days, they didn't know they were galaxies. They didn't know that concept at the time. So he found that these nebulae, except for Andromeda, were all moving at high speeds away from us. And they were moving too fast to be something in the Milky Way. They were moving far faster than the stars in the Milky Way. And so those observations then contributed to the debate that was going on at the time over what was the nature of these nebulae. There was are they in the Milky Way? And just like the other nebulae that we see in the Milky Way that are star-forming regions or planetary nebula or whatever, or are they something outside of the Milky Way? And so his observations showed that they had to be objects outside of the Milky Way. And eventually that led to the concept of all of these objects also being galaxies like our own Milky Way. And then the other thing was that they were running away from us at these high speeds, and that led to the concept of the expanding universe. And so, you know, two major concepts that were resolved in those decades, these data played into that. So he helped determine that these nebulae were galaxies and that the universe was expanding. Eventually, people would figure out that the speed at which the galaxies were moving away was also related to how far away they were. And so galaxies that had very low redshifts were nearby, and those with very high redshifts were further away. And that was very important. And people then began studying the nebulae and classifying them as spirals and elliptical galaxies. And all of that research then led to the idea that there are these different kinds of galaxies. And eventually people found, it was in the early 1950s, Gibson Reeves was one of the first people to actually study the dwarf galaxies in the Virgo cluster. And so people became aware of dwarf galaxies. And eventually I came along and carried on the work that Paul Hodge and all these other people had done before me, studying in more detail nearby dwarf galaxies. So one of the really neat things about astronomy and science in general, but astronomy, is that that we build on what people have done before us, right? We're always building on all of the work that came before us.
It's the quote that's been attributed to many people. If we see further, it's because we stand on the shoulders of giants. And VM Slipher was certainly a giant. We have a question here from Nicholas. Didn't the spectrograph have multiple prisms removed to reduce the light loss, what resulted in the spectrum to be very small to analyze? That's exactly right. VM Slipher, in a letter to Percival Lowell, had written, I've realized that while the telescope is important, the real key here is the speed at which the spectrograph is working. And maybe Deidre, you can explain that a little bit more in a minute. But what they did was he took it out and he said using parts lying around the observatory, he turned it into a single prism spectrograph. And yeah, the resulting spectra were tiny. The plates we have here, you needed a special device to be able to analyze them because they're really tiny. But that's what did the trick by improving the speed of the spectrograph. So maybe you can talk about that a little bit, Deidre.
Yeah, it just
increase the speed.
It just means that you take something that is, if you have something that is big and fuzzy, but and really faint, we would call it low surface brightness. If you take that light and you spread it out over a large, say, photographic plate, then it's hard to detect the light. But if you squeeze that light together into a smaller image, then you can detect the light better. And I would like to, let's see, I would like to make another connection, if I can, that this wasn't done with the Clark, but another person came to Lowell Observatory brought their own spectrograph with them. That was Vera Rubin and Kent Ford. And they used a telescope out at Anderson Mesa, 1.8 meter telescope. And this had another technological innovation on it. It was an image tube. So it took the light that was coming in, and they still they still use photographic plates as the detector, but the image tube enhanced the light that was coming and hitting the photographic plates. And that enabled the two of them to get spectra to continue the work of VM Slipher and to get spectra, not in days, but in hours, of showing the starlight in galaxies and how at this and tease apart the rotation of the stars in the galaxies and show that they weren't rotating. The stars were not rotating at the speeds that you would expect, that they were, instead of rotating faster as you went out from the center and then dropping off as you went out into the outer galaxy, the speed went up and it stayed flat. And this led to the understanding that galaxies had a lot of matter in them that wasn't visible. It wasn't part of the starlight. It wasn't part of the gas that we can see. And that meant this is what we came to call dark matter. And that was another transformational moment in astronomy because it completely changed our view of the universe.
And that's such a great historic story, and the ties to the observatory. She not only used the Perkins telescope and the 2.1 meter Kidd Peak, but the testing they did on that was with a telescope up at what is euphemistically called the Chalet here, which is now being turned into our wood shop. But it was, you think back at those cold nights that they were here, just trying to test this instrument and make it work. I don't know if they had any idea that, the kind of discovery, and, they were just doing this certain set of research. You just never know what you're going to find. And in that case, it was years before it really built up momentum of how important it was, I think, because it wasn't really understood.
When Vera Rubin first announced their first discoveries, the first galaxies they measured, people didn't believe her. They said, that's wrong, it can't be.
Yeah. Oh, what a legend she was. And she had such an important impact on your career. And we have just a few minutes left here, so maybe we can go to another image of the Sombrero with Lowell Discovery Telescope, that image. And then Deidre, maybe you can just end with talking a little bit about how Vera Rubin impacted your career.
I had the pleasure of being a postdoc. I mean, I finished my graduate, my PhD dissertation. I went to Kidd Peak National Observatory for 2 years, and then I went to the Carnegie Institution in Washington, D.C., the Department of Terrestrial Magnetism, where Vera Rubin was there. And I got a chance to work with her for 2 years. And I continued to work with her off and on after that for a while. But she was just an amazing person because she was so real. She was so down to earth. She transformed astronomy, but she was just such a humble and amazing, warm person who opened her heart and her home and her research to postdocs like me.
That's neat. And as we wind down, we've got the Sombrero through the Clark, and if we can get, I can't quite see it on my device here, but as we wind down with the image, you can see the difference between seeing a live image through the 24-inch refractor and an image that I'm not sure how long the exposure was, but it's also through a telescope that is much, much bigger. The 24-inch has 24-inch diameter. The Lowell Discovery Telescope is 14 feet in diameter, so it has a lot more light gathering capability. So yeah, here we've got it up here. I can see. You can see the difference between the LDT, but when you look at this, and you realize, there's something like 800 billion stars or something like that in the Sombrero Galaxy, a couple thousand globular clusters, clusters of stars. It's really pretty neat to be able to capture this, and you can see it takes pretty much the whole field of view because it's so spread out. So I'm glad we were able to end. We just had to wait for it to get dark enough to be able to see it well. So what a great way to end a great night. Thanks, Deidre, for joining us. Thanks for talking about VM Slipher. Thanks for telling us about how you got interested in astronomy and how you're inspiring students today to do the same thing. Thanks for our production team, Danielle Adams and Heather Craig, and our educators at the telescope. I know Sarah Bircher's there, I'm not sure who else. And thanks everybody for joining us. We'll see you next month as we continue to celebrate the 125th anniversary of the Clark Telescope. Good night.